Okay, the last few problems. So this one, this is number 9 out of 11 for your practice problems, and it's pretty straightforward. We are given the betas of 4 different stocks, which I've gone ahead and transcribed over here, and we've got a couple of different portfolios with different weightings of each stock, and we need to calculate the beta of the portfolios. Now I'm going to show you how to do it, and it's going to give me an error message. Okay, so I want to show you what that's going on. So, you know, the beta of the portfolio is just the weighting times the betas of each individual stock, right? So we use our handy dandy sum product function, which gives us a weighted average. Okay, so if I invoke the sum product of this array and then the betas, it returns 0. This is 0. Why? It shouldn't be 0. I've got 25% of a whole bunch of positive numbers. Well, that's a problem with the way that this table was carried in. I brought the data in from this table icon here, and I actually copied it over onto a spreadsheet. And you see these little green triangles in the corner? Those indicate that there's something strange going on in the cell. So if you click on this little triangle with a exclamation point, it tells me that the number in the cell is formatted as text, right? So it's not recognizing these numbers as numbers. So what you can do, if you just click on that, we can convert it to a number, and now all of a sudden my weighted average starts giving me positive numbers. Okay, so I paused I cut the video for a minute while I did all those conversions, and we see that we have a weighted average beta here for our first portfolio of 1, which is correct. And so then, you know, this is very simple. You just, if you set up your sum product right, you can again go ahead and just use these as a absolute cell value, copy that down, and then this will just give you the correct answers. Easy peasy. 0.84 for the second one and 1.15 for the third one. So there it is. Okay, so let's look at the next one then. Okay, so here we have the same, oh no, they're not the same beta values. Okay, so let's clear our data here. Okay, so the betas of 4 stocks are 0.46 and 0.84 and 1.05 and 1.59. Okay, now note I've still got my weighted average equation in here, my sum product. Okay. The beta of portfolio 1 is 0.099. All right, so let me just make a new column, say given beta, portfolio beta. Okay, so that's 0.99 and 0.84 and 1.11. Now, in order to address this, right, we have to look at the equation for the security market line. So let's go back to the book and see if we can find our equation there in the book. Okay, so this is from the capital asset pricing model, which is the last material we covered. And this is the idea that there is a relationship between the risk of a security, any individual asset, and the expected return of the market as a whole. And so the slope of the security market line is the ratio of the expected reward to the systematic risk, the risk of the market as a whole. And you know, the y value of the line is equal to the slope times the x value plus the intercept, right? And so we have for this application then the expected return of an asset is equal to the risk-free rate plus the difference between the market expected return and the risk-free rate times beta. Okay, so this is our equation that we're working with. So I've gone ahead and split my screen so that I have the equation up here, I have the homework down here. Okay, so the expected return, let's see if we can set it up in Excel. So we have the risk-free rate. I find it's usually easier to think in English rather than Greek. So the risk-free rate, we are given this at 3.5%. Now when we speak of market premium, that is in fact this middle term here. It's the difference between the market return and the risk-free rate. All right, so that's important to keep in mind. Okay, so we now have an equation that goes, the expected return on an asset is equal to the risk-free rate plus the market premium times the beta of whatever it is that we're looking at. So, ready? Here's our formula that we use. So we can say expected return. Okay, for stock G, it's going to be the risk-free rate plus the market premium times beta. We'll give that in a percent with 2 decimal places. So let's see if this is right. Okay, so now that we have verification that this is right, we can go ahead and set this up to automatically calculate. Let's see, so we are looking at B8, which is a risk-free rate. We want to keep our column constant, and B9. We also want to keep the column constant, but we want to let that be 6 change, right? So that's 7.64. And we can go ahead and just multiply this, or pull this across. All right, so the expected return then of stock H is going to be 11.06. And stock I is going to be, let me make this taller. Stock I is going to be 12.95. And stock J is going to be 17.81. Okay. What is the expected return from portfolio 1? Well, we just go ahead and do the same thing, right? Expected return of the portfolios. It's the exact same equation, right? We just take and apply, let's see, we'll go 1, 2, and 3. So the expected return from the portfolio is the same equation, right? It is, go back up over here and see how good I am at memorizing this stuff. Okay, it's the risk-free rate plus the market premium times the beta of the portfolio. Now this time we can go ahead and pull this down, but we need to treat the absolute cell values a little bit differently. In this case, we want to let the row values remain the same as we pull this down through multiple rows. I think that'll work. Yeah, that looks pretty good. Okay, and we can see, actually, if you step back for a minute and think about what this is saying, right? We are being told here that the expected market rate of return is 12.5%. Right, it's 3.5 plus 9. So this is what we're expecting the market return to be. With a beta of 0.99, that's going to get us to pretty much 12.5, right? 12.41. So this makes sense from an eyeballing perspective as well. And so what that means is if you have a portfolio with these weights and with these betas that are kind of all over the place, you can wind up with a portfolio that looks a lot like the market. So let's see, it's 12.41. And 11.06. And 13.49. Okay, so there it is. So that's how you use beta to estimate the returns on both individual assets and on portfolios. The Royal Seattle Investment Club had $100,000 to invest in the equity market. Fraser, oh, this is funny. These names are all from a TV show. Did you guys ever watch Frasier? Fraser advocates investing the funds in KSEA radio with a beta of 1.4 and an expected return of 15.9. Niles advocates investing the funds in Northwest Medical with a beta of 1.1 and an expected return of 14.1. The club is split 50-50 on the two stocks. You are the deciding vote, and you can't pick a split of $50,000 for each. Before you vote, you look up the current risk-free rate, which is 3.5%. Which stock do you select? Now, in order to solve this one out, I want to look again at the book. So if we go back to the graphic of the securities market line, the intercepted line is the risk-free rate with a beta of 0. And the slope of this line is the ratio of the reward to risk. So again, what we're looking for here is just the slope of a line, where beta is the denominator and the return is the difference between the risk-free rate. Here, I'll write it down. We want the slope of a line where beta is the change in x, right? So the denominator of the slope equation and the difference between the risk-free rate and our securities rate is the change in y. Okay, change in y over change in x is a slope, right? We have a KSEA, right? So the beta is 1.4 and return, expected return is 15.9%. Okay, so this is an investment that moves more than the market. It's quite volatile. And then Niles wants medical, and the beta is 1.1, a little bit less risky, and the return of 14.1. Okay, the risk-free rate is 3.5%. Okay. So let's just do our little subsidiary calculations here. Okay, so the change in y is going to be 15.9 minus 3.5. And the change in y for Niall's pick is going to be 14.10 minus 3.5. Okay, so that's our change in y. All right, and the slope is the beta. So let's just say, this is our slope. I'm sorry, this is our change in x. This is our change in y. So now we can say our reward to risk ratio is just simply, here's our reward, and here's our risk. And we want to give this in percentages with 2 decimal points. So we'll do that again. Here's our reward, and here's our risk. $9.64. And sure enough, let's make sure we get it. The choice is Northwest Medical with a higher reward to risk ratio of 9.64. So that's going to be it. We'll check it. And it is right. And so that, my friends, is one of the ways that you can go about picking stocks. You pick the stock with the best reward to risk ratio. That's how you pick a stock. That's how you get rich. Not guaranteed, but that's how people invest. Okay, so that's how you do the homework. Have fun with it. It's a lot of math. Hopefully you'll be able to step back and not just follow along with what I'm doing, but actually understand what I'm doing. But that just takes practice, so spend your time practicing. This is good stuff. Okay?